Okay, in this video, we will use row reduced echelon form to solve the system of algebraic equations. So we have x1 minus x3 is equal to 0, so 0x2. 3x1 plus x2 plus x3 is equal to 1. Minus x1 plus x2 plus 2x3 is equal to 2. And next we will construct the matrix table, essentially. And so we don't say x1 or x2 or x3. We just say the constant. So this is 1x1. So we write 1. We have 0x2, so 0, minus 1x3. And we do a dashed line to represent is equal to this term, so 0. Next we have 3x1, so 3, 1x2, so 1, 1x3, so 1 is equal to 1, so simply we're at 1. Minus 1x1, so minus 1, 1x2, so 1, 2x3, so we write 2, is equal to 2. And so with row reduced echelon form, what we want to do is ultimately make something like this, where most of our terms will be 0, except 1 for one term, 1 for the other term, and 1 for the last term. And so we can do that by manipulating our matrix. For example, we will manipulate this line to produce something with a 0. And we can do that if we say minus 3 of this guy, of this line, R1, plus this R2. And so what we're doing here is saying we're getting R2, so 3, 1, 1. But now we are going to subtract this line by minus 3R1. So we're multiplying this line right here by negative 3. So minus 3 plus 3. And we're just adding it only to the second line. So it would be 3 minus 3, so 0. 1 minus 3 times 0, so 1. And 1 minus 3 times negative 3. So 1 plus 3, so we get 4. And lastly, 1 plus minus 3 times 0, so it would remain the same as 1. And we continue this process until we get something like this. And so the next thing that we can do, we can say R1 plus R3 for R3. So we're going to manipulate this line now, just this line. And so if we say R3, this line, plus R1, what we're going to get is negative 1 plus 1, so 0, 1 plus 0, so 1, 2 minus 1, so 1, and 2 plus 0 is 2. And if you notice, this whole time we're doing this, we're keeping this line the same. We're not changing it. We're just changing one line at a time. And so we get this. Next, we can say minus R2 plus R3, and we're just going to change R3, just this line right here. We're just changing the last line. And by doing that, this is what we're going to get. So R3, 0 minus 0 is going to be 0. 1 minus 1 is 0, so we have 0 now. 1 minus 4 is going to give us negative 3. 2 minus 1 would give us 1. So this is what we have now. We're getting more zeros. Next, we will say... Next, we're just going to actually just mess with this line to make it even a little bit more simpler. If we multiply this line by minus 1/3, we would get 0, 0, 1, and then negative 1/3. And now that we're used to like messing with one line at a time, now I'm going to do 2 lines at a time. And so if we say R3 plus R1, where we're manipulating only R1, we're just manipulating this line right here. And so what we're going to do here is add R1. So 1 plus 0 is going to be 1. 0 plus 0 is going to be 0. Negative 1 plus 1 is going to give us 0. And 0 minus 1/3 would give us negative 1/3. And now we'll do the next thing. So minus 4R3 plus R2 to only manipulate R2. So we want to manipulate just this line, just the second line. That's all we're manipulating. And so if we say minus 4R3, so minus 4R3, minus 4 of this, plus R2, plus the one we're going to change. And so 0 times negative 4 plus 0, it's still 0. 0 times negative 4 plus 1 is going to give us 1. And 1 times negative 4 is minus 4, plus R2 plus 4 would give us 0. And lastly, minus 4 times negative 1/3 is 4/3 plus 1, so plus 3 over 3 would give us 7/3. And now we have in a nice form that we can get our final answer for x1, x2, and x3. And so we're saying that this line right here is representing x1, this is x2, and this is x3. We're saying this because initially when we did this, we said x1 was 1, x2 was 0, and negative x3 was negative 1. So x1, x2, x3. So x1, x2, x3. And so we can conclude that x1 would be negative 1/3, x2 would be 7/3, and x3 would be negative 1/3. And so we solve this linear system using row reduced echelon form. And that's all we need to do.